In this figure, we are given a square which has side length 2, and inside the square we have this shaded region for whose area we are required to find. We're going to start by labeling the points of this square. Let this be A, B, C, and this D. The next step is we're going to draw a diagonal from point A to point C. So, just like that. So now we're going to consider 3 figures formed out of this. We're considering 3. So the first one is this one here, separated by this line. This one, where this is A and this is C. Okay? And also we're going to look at this here. Where this is A, this is B, and this is C. Also, we're going to look at the triangle formed. Okay, this is A, this is B, and this is C. Now, from here or from this, we can see that this one here, the area of this, just to find the area of this one here, this part of the shaded region, it will be equals to the area of this here minus the area of the triangle. So this part of the shaded region is equals to this one here is a quarter circle minus this triangle. So let's start by finding the area of the quarter circle. So this is the quarter circle. This is A, B, and this is C. And the radius is BC, which is 2. We know that area of a circle is pi r squared. But since this is a quarter circle, we shall multiply by a quarter. Okay? Therefore, area is equals to a quarter times pi. Radius is 2. So 2 squared. So this is equals to 1 out of 4 times pi times 2 times 2. This cancels with this to give 2. This cancels with this. So we are left with just pi times 1 times 1, which is just pi, as the area of the quarter circle. Then for the area of the triangle, this one here, so for the triangle A, B, C, since BC is 2 and also BA is also a side of the square, which is also 2. So area of this one is a half times base times height. Therefore, area will be equals to a half times the base is 2 and the height is 2. So this cancels with this, and area is 2 square units for this triangle. Therefore, the area of the half shaded region, we said its area is equals to area of quarter circle minus area of triangle. Okay, so the area, we found the area of the quarter circle to be pi, and the area of the triangle we found it to be 2. Therefore, area is equals to pi minus 2 for only this one here, for half of the shaded region. But since AC bisects this square into 2 equal parts, that means that half of this shaded region is equals to the other half of the shaded region. Okay, therefore area of shaded region is equals to 2 times area of the half of the shaded region, which is pi minus 2. So area is equals to 2 times this. 2 times pi is 2 pi minus 2 times 2 is 4, which is approximately equals to 2.28 square units. So this is the area of the shaded region. In this figure, we are required to find the value of angle x. So we have this angle here is x, this angle is 40 degrees, this angle is 20 degrees, and they're telling us that this line is equals to this line here, from here to here. So with that information, let's find the value of angle x. Let's start by labeling the points on our figure. Let this be A, B, this C, and let this be D. Now next, let us extend this line DB towards the left up to a point, say E, such that when we connect that point E to A, we form an angle of 20 degrees at that point E. So let me do that. So when I extend this line, say up to there, and I'm calling this point E, and then connect A to E, I should be able to make 20 degrees here. I know the diagram is not to scale, but I'm sure you get the point. Now that we can see that this angle is equals to this angle, so that implies that this side here, AE, is equals to this side, AC. And so we can conclude and say triangle AEC is an isosceles triangle. Okay. Now we know that from the exterior angle theorem, the exterior angle of a triangle. So if you have something like this, the exterior angle of a triangle, say this one here is y, which is the exterior angle. It is equal to the sum of the two opposite interior angles. So let's say this is alpha and this is beta. Okay, so from exterior angle theorem, y is equals to alpha plus beta. So following this, in our diagram, considering this angle 40 as the exterior angle, that implies that this 40 will be equals to 20 plus this angle here, this one. Okay, so that implies that angle ABD is equals to angle AEB plus angle EAB. Okay, so we have this angle is 40, then AEB is 20, then this is the angle we don't have. Therefore, angle EAB will be equals to 40 degrees minus 20 degrees. which gives us 20 degrees. Therefore, this angle here is 20 degrees. Now, since in this triangle BAE, this angle is 20 degrees and also this angle is 20 degrees, that implies that this triangle is also an isosceles triangle, implying that this side AB is equals to side EB. Okay? Although the diagram is not to scale. And with that, according to side angle side theorem, that implies that triangle EAB, this one here, is congruent to triangle CAD, this one, due to side angle side theorem. So as you can see, this side is equals to this side, this angle is equals to this angle, and this side is equals to this side. Now, if this is true, then since in this triangle here, the angle that corresponds to the side that corresponds to this angle of 20 degrees is side AB. Okay, so that implies that the side that corresponds to the one that is equals to this in this triangle, which is DC. So remember, DC is equals to AB, and the side that the angle that corresponds with AB is 20. That implies that also in this triangle here, the side that corresponds to DC is also 20 degrees, and that side is X. So that means X is equals to 20 degrees. Hope you've understood that.